The next force we're going to talk about is called static friction. There are several frictional forces out there. Static friction being one. We'll talk about kinetic, but we will not cover like rolling friction. But static friction is called static friction for one simple reason. If you were to look really close at the surface of any object, whether it be a piece of plastic, whether it be a piece of wood, whether it be steel, whatever, you can look at that object, and if you were to examine it under a microscope, that you would notice that that surface that object is not very smooth. It's actually quite rough, depending on how close you look at it. Well, when you place an object on top of another surface, those roughness, those ridges, tend to sink and align themselves so that the object tends to slide into those ridges and then hold itself tight. Okay, so when we talk about static friction, what has ended up happening is an object is now at rest and has slid itself into those ridges. Now, static friction is the type of force that is resisting motion. It's trying to stop motion. It's trying to stop motion between these two objects. Okay, and those ridges are locked into place. So that we call static friction. An example of you experiencing static friction would be moving a couch across a carpeted floor. Well, any kind of floor, but a carpeted is nice and has a lot of static friction. You push on that couch, and you don't get it to move. That is static friction. Okay, so there's no motion in between the carpet and the couch itself, because the roughness of the legs of the couch and the roughness of the carpet have now kind of interlocked themselves and are now going to resist any kind of motion in between them. Okay, but the thing with static friction is if you can apply enough force to the system, that those interlocking ridges eventually break free and the object is allowed to move. Okay, so that's kind of what static friction is. The equation for static friction is static friction. This is our expression for friction. The S is just meaning that it's static, is equal to mu sub S. Now, mu sub S means coefficient of static friction. Now, that coefficient term is just telling me, not specifically, but in a kind of a way, how well those surfaces are interlocking with each other. High coefficients means that those objects interlocked quite well and take a considerable amount of force to get them to move. Okay, so it's this coefficient, which describes how well these surfaces are interlocked, times the normal force, times the amount of force that this surface has to respond to all that downward forces onto it. Now, why not weight instead of normal? Well, you want to say normal because normal is the amount of pressure that you're pushing down on those two surfaces. Much like a piece of sandpaper. If you have a block and a piece of sandpaper, you can push down really hard on that block, and it makes it very difficult to sand. So pushing down actually increases your normal, but it does not increase your weight. So in order to convey that idea that it's how much I'm pushing down with, we use the normal term, which is the response to how much you're pushing down with. And so that would include weight in some cases. It will include an applied force in some cases, depending on the situation, of course. So the coefficient of static friction, which is how well those surfaces are interlocked with each other, times the normal, which is how much force I'm applying down on that surface. And so that's the normal force. So that's the equation. What I have here is I've had the force of friction versus the applied. So if you were to apply a force on an object, so you're applying a force on an object, you can see that the force of friction responds equally to the amount of force applied. So if I look at this graph and I'm applying 1 Newton here, which is the unit of force, I'm going to get 1 Newton of friction. Okay? So as we go up, for every Newton of force I apply, I'm getting a response of exactly the same amount of frictional force. So I'm responding with exactly the same amount of static friction that is being applied to the object. So if I push that couch with 5 newtons of force, which is not enough to move it, the force of friction is not responding to the full value that it can possibly do, but it only is responding to the 5 newtons of force that you're applying. If it goes up to 10 and it still doesn't move, that means that the force of friction, the static friction, is responding at 10. But what is interesting is this point right here. This is the point in which the object starts to move. That point right here is saying that the force of friction is exactly the value of mu static times the normal. That's the maximum value that you can achieve with static friction. This point right here, now I should draw a big arrow to it. Everything below it means that the force of friction is less than that. It's smaller than that. It's responding to it. But this is the breaking point. This is the point where the force of static friction is identical to the force being applied, and this equation of mu, coefficient of friction times the normal. Okay? So that is the force of static friction. Now, what we have here in this region is what's going to be called kinetic friction. But it's much of the same principle. But remember a couple of things. There's a couple of things you have to know about it. If I have these two objects applying to each other, there's two surfaces. There's a normal that's responding back to it. Okay? The force of friction is going to be perpendicular either this way or this way to that normal. So here's the direction. That may be, it may be in either one of these directions. It actually may be out here or out here, but it's perpendicular to that normal force. Okay? Or you can say it's parallel to the two surfaces that are in contact. Okay? That's one thing you have to know. The other thing you have to know is that the force of static friction is less than or equal to that value, which means that the force of static friction will match the force that you're applying to the system up until this value. Once you've exceeded this value, then you've overcome the force of static friction and the object starts to move. Oh, that was the other thing I need to remind you of when we talk about static friction. There's no motion between this object and this object. These objects are sliding together. They're not moving separately. There's no motion in between these two objects. This one's not moving away from this object. They're moving together or they're stationary together, but there's no general motion in between them. Okay? So that's the force of static friction. We'll talk about this region right here, kinetic friction, next. And that's it.